Yes, we were discussing about this problem, and we have written the given things. All of you have written the given things, all these things here: viscosity, then diameter of the pipe, length of the pipe, mass of the fluid oil, and time required for the collecting this oil. Now, what is asked here? Calculate the difference of pressure at the two ends of the pipe. Okay, the length of the pipe is given of 10 meter. So what will be the difference in the pressure? Let us say P1 is the pressure here and P2 is the pressure here. So we have to find out what is P1 minus P2. That difference it is asked to find out here. Okay, so the difference of pressure P1 minus P2 for the viscous or the laminar flow is given by equation. This is the Hagen-Poiseuille equation that we have seen in the last slide. You might have noted there. Hagen-Poiseuille equation P1 minus P2 upon rho z is equal to 32 mu into u bar L upon rho z d square, right? The same equation that we have to use here. Where u is the u bar is the average velocity, and whatever the velocity we get by dividing the discharge by area, cross section area, that velocity is nothing but it is the average velocity itself. Okay, so whenever we divide the discharge by area, we get the average velocity. So here average velocity q upon area, mass of the oil per second, mass of the oil per second will be 100 upon 30. 100 is the kg and 30 is the time that is given here. So this rho 0 into q, okay, rho 0 into q, what is this rho 0 now? This rho 0 is nothing but it is the density of the oil. Oil has a specific gravity 0.9, right? So if specific gravity SL is equal to या ठिकाणी S0 म्हटलेला आहे, याला आपण नोटेशन S0 घेऊया. ऑइल साठी SO म्हणूया. SO upon SO is equal to rho O divided by rho W. So rho O is equal to pi SO into rho W. What is SO? SO is 0.9 into rho W is 1000. So I will get here 900 kg per meter cube as the mass density of the oil. Okay, and if I multiply the mass density of oil by discharge, then I will get this quantity, because mass density has the unit kg per meter cube and discharge has the unit meter cube per second. So it will get cancelled and you will get the unit kg per second. So this kg per second unit you will get here if you multiply the density by the discharge. Okay, so here 900 cube is equal to 300 by 30. So this 20 will get cancelled with this one, and you will get the q value as like this 0.0037 meter cube per second. This is the discharge. Now we got the discharge and we need to find what is the area, as the diameter of the pipe is known to you. So you can find out what is the area of the pipe, right? And if you divide this discharge 0.0037 by area, then you will get the average velocity u bar. Okay, and once you get this average velocity u bar, then let us find out whether flow is laminar flow or turbulent flow. And how to know whether the flow is laminar or turbulent? By using Reynolds number, we can find whether the flow is laminar or turbulent. What is the Reynolds number equation? R is equal to rho VD upon mu. Now this mu is given, this diameter is known to us, velocity we have found here, and this rho is also specific gravity is given, but we have found the rho also there. So putting all this value, we will get the Reynolds number. Okay, so first find out what is the Reynolds number. So they have found here the Reynolds number as 436.91, and This Reynolds number is less than 2000, and so we can say that the flow is laminar flow. Okay, or it is a viscous flow. हे असं आपण या ठिकाणी म्हणू शकतो. If the flow is laminar flow or viscous flow, then we can go for Hagen-Poiseuille equation. That is nothing but this equation we can use. P1 minus P2 is equal to 32 mu into U into L upon D square. And after that, putting these values in this equation, you will get the pressure difference as 1462.28 Newton per meter square. Okay. Or if you want to find the answer in Newton per centimeter square, then you can convert that by multiplying the answer by 10 to the power minus 4. Okay. So do the calculation part in your notebook. Is it over? Everyone? All of you have written the problem in your notebook or not?
Yes, sir.
Is something previous remain to write from the previous slide? Or no? Is it over? So let us see the next problem. An oil of viscosity 0.1 Newton second per meter square and relative density 0.9 is flowing through a circular pipe. Is flowing through a circular pipe of diameter 50 mm and length 300 meter. The rate of flow of fluid, the rate of flow of fluid through the pipe is the rate of flow of fluid through a pipe is 3.5 liter per second, 3.5 liter per second to stop. Find the pressure drop, find the pressure drop in a length of 300 meter, find the pressure drop in a length of 300 meter and also the shear stress at the pipe wall, also the shear stress at the pipe wall. We have written the problem, then write down the given things. The procedure is similar to the previous problem, just you have to follow that. Also, shear stress we need to find at the pipe wall means we have to use the equation of shear stress distribution, and we need to find out what is the value of tau 0. So first of all, let us solve it for the first find out what is pressure difference, and then we'll see how to find out the shear stress at the pipe wall. Don't look everything on the slide or the screen. See how you have solved the previous problem. Take the help of that previous problem step by step. First, find out what is U bar, then find out what is Reynolds number. Check whether that Reynolds number is less than 2000 or not. If it is coming less than 2000, then we can say that the flow is
त्याला एवढा होत आहे, आपल्याला काय प्रॉब्लेम गाडी सायकलीवर सायकलीवर आणि ते हे कडून कॉलेजला एकदा नर्मदा पार्कला एकदा गावात जायला
after knowing that flow is viscous flow, we can use the Hagen-Poiseuille equation P1 minus P2 upon is equal to this equation. Pressure drop P1 minus P2 is equal to See here, the question might have come in your mind that here in the denominator rho z you have written, and but here see this rho z it will get cancelled, and you will get this equation only p1 minus p2 is equal to 32 mu into mu bar. As this is the HF, that is the head loss, so that's why it is divided by rho z. To get the head, actually we are interested in pressure intensity, so that's why this rho g is not considered here. Pressure difference we want only, and that's why we have written this equation. P1 minus P2 is equal to 32 mu into u bar L upon d square. So have you found what is the pressure difference between these two ends of the pipe? Anyone? If you have got the answer, you put your answers in the chat box. 28.513 Newton per meter square. Okay. Thirty-two into mu is 0.9 into u bar. What 1.782 into L, the 300 length divided by d square is 0.05 square. One, two, three, 4, 615 Newton per centimeter square. Snehal, check whether what has gone wrong. Something is wrong here. Because answer is 6843. I'm also getting the wrong answer. 3000. Length is 300. They are written here 3000. By mistake, they might have printing mistake, but yeah, 300. But even that